Hi everyone, my name is Han Lin, and I'm gonna do the question 5 of homework 2, whose video is required, so let's begin. Okay. So it tells us the customer flow at a grocery store can be viewed as a Poisson process, so the random variable, the number of customer arrives in a period of time, it actually satisfies the Poisson distribution equals to the minus lambda t power of e times the kth power of lambda times t divided by the factorial of k. So the first problem tells us to find lambda. We have to use the condition that the problem gives us. It says that the probability that in 2 minutes at least one customer arrives equals to 0.3. So actually, at least one customer, it can be 2, 3, and 2 infinite. So we have to use the start of complementation. At least one customer arrives in 2 minutes. The complementation of it is the number of customer arrives in this period of time equals to 0. So the probability of at least one customer arrives, it actually equals to 1 minus the probability of the number of customer arrives in this period of time equals to 0, and it says 2 minutes, so at this situation the t equals to 2. So we should simply just substitute the Poisson distribution into it, so it equals to 1 minus t is 2 and it has lambda, so it's the minus 2 times lambda's power of e, and it times still t equals 2, and here k equals to 0 because it equals 0. So it's the 0's power of 2 times lambda and divided by the factorial of 0. It still equals to 1. So the 1 minus that equals to 0.3, like as the problem gives us. So we have an equation that 1 minus the minus 2 times lambda's power of e equals to 0.3. So through this equation, we can get the lambda. It equals to minus ln 0.7 divided by 2, and it approximately equals to 0.178. So that's the lambda we need to get. And for the second subproblem, it tells us to find the probability that in 3 minutes no customer comes. So as we said in the first problem, it actually is just the probability of the number of customer arrives in this period of time. Here t equals to 3, so and the number equals to 0, which means the k equals to 0. So simply we just substitute the Poisson distribution into it, and here it equals to the minus 3 lambda where t equals 3, so it's 3, the minus 3 lambda's power of e times here k still equals to 0, so it's the 0's power of 3 lambda divided by the factorial of 0. So it equals to minus 3 lambda's power of e, and we just substitute lambda into it, and it approximately equals to minus 3 times 0.178 power of e. It approximately equals to 0.586. And for the third subproblem, it tells us to find the probability that in 10 minutes at least 2 customers arrive. So here we still have to use the source of complementation, at least 2 customers, and the subcomplementation of it is 1 customer or 0 customers. So it equals to 1 minus the probability of the number of customer arrives in this period of time. Here t equals to 10, so the number of t equals 0. We still have to minus p the same, in this equals to 1. So we still substitute the Poisson distribution into it, so it equals to 1 minus minus 10 lambda power of e, 10th still here k is 0, so the kth 0's power of 10 lambda divided by 0, the factorial of 0, and we have to minus when k equals to 1 and t equals to 10. So it's this. So it equals to 1 minus 10th times lambda's power of e times 1 plus 10 times lambda. Yeah. So it approximately equals to, when we substitute lambda into it, and the final result is approximately 0.531. And for the subproblem number 4, it tells that to find the probability that in 1 minute exactly one customer will arrive. So it's simply just the number of customer arrives in this period of time equals to 1, and still we substitute k and lambda into this Poisson distribution, and we get the final result as approximately 0.149. And that's all for the question 5. Thank you.